The idea behind this program is to demonstrate the basics of character animation on canvas using HTML and CSS. The main part is done by JavaScript. The character in this particular case is Santa. It is controlled by arrow keys and the Shift key. Santa can walk in both directions, run, jump, and slide. To perform all this, JavaScript needs a sequence of images called animation frames for each particular animation state: idle state, walking state, running state, etc. These images are organized in one PNG file, Santa_Spritesheet. This image, holding all animation frames, is called an animation sprite-sheet. To make it simple for the script to clip out the particular required frame, all frames have the same size, width 311 pixels, height 214 pixels. Santa can be in one of 6 states: dead, idle, jump, run, slide, and walk. Each state has a particular number of frames in the sprite sheet. To clip out a specific frame and draw it on canvas, the program must have such data as frame size and frame index, which counts from left to right, top to bottom, like this. Let's take a look at the code. All is packed in one HTML file with internal CSS styling and embedded JavaScript. The HTML structure is simple. The top-level container will occupy the whole viewport, canvas and image inside it. The image is the sprite sheet, and it is hidden. CSS ensures canvas will take the viewport size, maximum available space, and sprite-sheet image CSS property is hidden. Now to the main part, JavaScript. When the page is loaded, onload event is fired, and the initialization phase begins. Canvas dimensions are set to their parent container. My Santa is the instance of class Santa. That class holds all data and methods required to manage Santa state based on keys pressed. Update Santa horizontal and vertical position on the canvas, choose the respective animation frame from the spreadsheet, and draw this frame on canvas. Request animation frame starts the animation loop. Animation is controlled by the user. That's for there are 2 events, key down and key up. They call the same function, handle keys. It receives from the keyboard events event object E. The property key of the event object is the string representation of the pressed key, like arrow up, arrow left, shift. Some logic must be implemented to store the pressed key, because the key down event, when the key is pressed, fires repeatedly, but we need to store the key only once. That's why the keys variable is not a regular array, but a set. The set is a collection of unique values, meaning that when I add a key to it, it will be added only if there is no such key already present. We check the event's type property first. If it is the key down, the ternary operator adds a key to the set. Here is the comma operator implemented. After adding the key to set, we check if the set contains opposite keys, and if it does, delete just added key, because such commands have no sense. If check e.type equal to key down fails, means it is a key up event, and we must delete that key from the set. The function animate is the recursively looping animation loop. It loops with the monitor refresh rate frequency, meaning it is hardware dependent, and we cannot base the animation speed on it. To make animation hardware independent, for each frame we must calculate the time passed since the last canvas redraw. That's why at the start of the animation loop we calculate frame time to pass it as an argument to methods update in Santa. That way the animation will be time-based and run with the same speed on any PC. To make it clear, I split animation logic into 4 separate parts. Update state method will manage Santa states, walk, run, jump, etc. The update animation frame method updates the current animation frame based on elapsed time. The update position method updates Santa horizontal and vertical position. Render method draws animation frame from Spritesheet on canvas. The class Santa. To comprehend how it works, basic knowledge of JavaScript classes is required. Of course, such simple animation can be done without classes. But if you try to animate more than one character, and the rest characters will be controlled by AI, without classes it will quickly become unmanageable. The class Santa encapsulates within itself all data and methods required to manage Santa state, define animation frame from Spritesheet, calculate Santa's position on the canvas, and render Santa on canvas. That is object-oriented programming main principle. Object holds data and methods to manipulate that data. The new keyword with class Santa calls the special constructor method of the Santa class and creates an instance of class Santa. Look, the constructor method has all the data about canvas size, sprite size, a reference to Spritesheet, current state, and so on. All this data will be manipulated by 4 class methods: update state, update animation frame, update position, and render. There is one helper method, frame sx, sy, sw, sh. It will return an array containing 4 arguments required for draw image to clip out specific parts from the Spritesheet containing the animation frame. Well, I wrote a lot of comments here explaining how it all works, and in my opinion it will be more effective if you read comments and try to figure out by yourself what is what. Just one remark. The Spritesheet contains frames only when Santa is facing the right side. To animate when he is left oriented, I must flip the animation frame horizontally. That is done here. The HTML file location and link to the Spritesheet are in the description. I will scroll the file now. That's all for now. Have a nice one.